Hi, welcome back. In this video, I shall explain you about importance of variables. So, let me ask you a basic question. What is the derivative of x? What I am going to cover in this video is importance of variables. Importance of variables. Very good. What is the derivative of x? I am asking a basic question. What is the derivative of x? What is your answer? If your answer for derivative of x is 1, what is the derivative of x is my question, and if your answer is 1, very good, but unfortunately it is wrong because the derivative of x is 1 only when I am differentiating with respect to variable dx. So it depends on with which variable we are doing the differentiation. So the concept of variable is very important in differentiation. Suppose what is the derivative of y with respect to x? It is not 1, it is dy by dx. What is the derivative of y with respect to y? It is dy by dy, which is 1. So it depends on which variable we are differentiating with. Let me solve 1-2 examples so that you get an idea. First take an example. I would like to find derivative of derivative of t square with respect to x. So derivative of t square would be, what is the derivative of x square? 2x. So derivative of 2 square would be 2t into derivative of x with respect to t, that is dt by dx. It's the same thing. What would be the derivative of t square with respect to t? Derivative of t square with respect to t would be 2t into dt by dt. dt by dt is 1. So the derivative of t square with respect to dt would be 2t. But derivative of t square with respect to x would be 2t into dt by dx. So please make sure that you are very clear with which variable you are differentiating with. If not, we might land up in trap. So solve this example. Find the derivative of 5 times xy. I would like to find the derivative of 5 times xy. We know when we have constant times any function, the constant comes out. So 5 times derivative of xy with respect to x. I have two functions here, x and y, so I need to apply product rule. 5 times derivative of xy would be same as y into derivative of x with respect to x plus x into derivative of y with respect to x. So that would be same as 5 times y plus x into dy by dx. Very good. This would be the differentiation of 5xy with respect to x. So hope you are clear with this. So variable, please make sure that with which variable you are differentiating with. So d by dx of x is only 1. If I am differentiating with x with respect to y, I can differentiate with any variable. Generally we use x as variable. So if I am differentiating x with respect to y, the answer would be dx by dy. Okay. Once you are clear with this, let me explain you what is a composite function. Composite function. Yeah, can you guess what is the meaning of composite functions? If you are done with functions, definitely you would have done with functions, algebra, concepts before starting differentiation. What is a composite function? An expression is said to be composite function when one function is plugged into another function. An expression is said to be composite when one function is plugged into another function. For example, take sin x whole cube. I have taken a function which is sin x whole cube. This function is same as, we know algebraic function which is x cube. This function is same as plugging in sin x instead of x. If g of x is sin x, if f of x is x cube, let g of x be x cube and f of x is sin x. So g of f of x would be g of sin x. G of sin x would be sin x whole cube. It is same as plugging in the function sin x in the variable x cube. So I hope we are clear what is the meaning of composite function. Go. Once you are clear, if someone asks you what is the derivative of sin x whole cube, what is the derivative of sin x whole cube? Since you know the power rule, if you give me answer as 3 sin x whole square, you are not correct. The derivative of sin x whole cube is not 3 sin x square, there is something else too. The derivative of sin x whole cube is, let me explain you in detail in a new page. So the derivative of sin x whole cube would be, take a function sin x whole cube, derivative of sin x whole cube is, so 3 as derivative of x cube is 3x square, so derivative of sin x whole cube would be 3 times sin x whole square into derivative of sin x, because here function is not x, derivative of sin x. For example, take derivative of x cube. What is the derivative of x cube? Derivative of x cube is 3x square into derivative of x with respect to dx. Derivative of x with respect to dx is 1, so we are neglecting this, we are not bothered about this, but here the function is not x, it is sin x. So we should make sure that we do differentiation of the function which is plugged into other function. So the derivative of sin x whole cube would be 3 sin square x into, what is the derivative of sin x? Which is cos x, which is very good. What is the derivative of root of tan x? We know this is same as plugging in tan x in the function root x. So derivative of root x is 1 by 2 times root x, here x is tan x, into derivative of tan x. What is the derivative of tan x, which we have learned? So that would be 1 by 2 times root tan x into derivative of tan x would be secant square x. You can see my future videos, I will be solving number of examples in each and every topic, like composite function, product rule, quotient rule in each and every topic. Let me explain you the complete concepts. Once you are clear with the concepts and with few examples, then you will be very confident to solve any problem. So you can see my future videos if you would like to have glimpse at more and more questions. Don't think I am solving very few questions, because my intention here is to explain you the concept and make sure you are clear with that. Once you are clear with that, you can solve any questions. Solving questions is not a major problem. Make sure that you are clear with the concepts. Now, let me explain you the differentiation of logarithmic functions. So, take a function, logarithmic function. What are the logarithmic functions which you are aware of? So what is the meaning of, what is the difference between ln of x? What is the meaning of ln of x? Logarithm to the base e is called as ln of x. Ln of x is also called as natural logarithm. And logarithm to the base 10 is called as common logarithm. This is called as common logarithm. So the derivative of ln of x is derivative of log base x is 1 by x. This is the next formula after trigonometric functions. The next formula which you are going to see is logarithmic function. You have learned the power rule, derivative of x power n, and you have learned derivative of trigonometric functions, and now you are learning derivative of logarithmic functions. So then immediately this doubt might come to your mind. What happens if the base is not e, if the base is something else? What is the derivative of log x base 10? So I can write log x base 10 as derivative of log x base e by log 10 base e. Log 10 base e is same as ln of 10. What is the derivative of? It is a constant, so I am not worried about the denominator because it is a constant. I can just make it as ln of 10. What is the derivative of log e base x? Which is 1 by x. So answer would be 1 by x times ln of 10 would be derivative of log x base 10. Next, we shall learn about exponential functions. The differentiation of exponential functions. So far we have learned the power rule, trigonometry functions and the natural logarithm differentiation. Now it is exponential functions. Take a function, let y is equal to e power x. The derivative of y with respect to x would be derivative of e power x with respect to x. Derivative of e power x with respect to x would be again the same, which is e power x. So the answer is e power x. If you would like to ask me to do derivation of this, I can help you with that too. So take function y is equal to e power x, apply log on both sides, log means log base e. Take y is equal to e power x, then apply logarithm on both sides. If you apply logarithm on both sides, we get log y is equal to log e power x. Log means log base e. Now differentiating both sides with respect to x, differentiation of ln of x is ln of y is 1 by y into dy by dx. So this becomes x times log e base e. Log e base e is 1 and the derivative of x is 1. So I get 1 by y into dy by dx is equal to 1. So dy by dx is 1 into y would be y, but y is e power x here. So dy by dx of e power x is same as e power x. Would like to have differentiation, you can have. If not, it's not required. Just remember this: the derivative of exponential function, that is e power x, would be e power x. Then you might have a doubt: what is the derivative of e power x? Now next part is derivative of e power x. Derivative of e power x is e power x into ln of e. We can even derive this. Let y is equal to a power x, apply ln on both sides. So differentiating both sides with respect to x, ln of y derivative is 1 by y into dy by dx. Into this I can write as x into derivative of ln of a. It implies ln of y is x times ln of a. It's not t, this is ln of y. Let me add this so that we will not have any confusion. So ln of y would be x times ln of e. So this is a product rule because x and ln a two functions, but ln of a is a constant function, so you can take it as ln of a into derivative of x. If not, you can apply one product rule, you get the same answer, plus ln of a into derivative of x with respect to x. So 1 by y into dy by dx is equal to x into derivative of x with ln of a with respect to x would be 0, x into 0 is 0, plus ln of a into derivative of x with respect to x would be 1. So dy by dx is y times ln of a. But what is y? We have taken y as a power x. So the derivative of a power x would be derivative of a power x with respect to x would be a power x times ln of a. Excellent. Let me solve few questions so that you get idea about this exponential functions too. Take an example. I would like to find the derivative of e power 3x. The derivative of e power 3x is e power x is e power x, so e power 3x would be e power 3x, but it's a composite function where 3x is plugged into x into derivative of 3x. So make sure that you derive even the composite function. So e power 3x into derivative of 3x is 3, so the answer would be 3 times e power 3x. Next question: what is the derivative of e power x plus a power x with respect to x? So we have learned algebra of derivatives. So if we are adding two functions, the derivative would be d by dx of e power x plus d by dx of a power x. D by dx of e power x is e power x and d by dx of a power x is a power x into ln of a. Okay. Now let me help you. As I said, let me complete all the concepts, then we solve good amount of problems in each and every concept. Inverse trigonometric functions. So like trigonometric functions, we do have derivatives for inverse trigonometric functions like sine inverse of x, cos inverse of x, tan inverse of x, cot inverse of x, secant inverse of x and cosecant inverse of x. So let me derive for one or two functions. Other functions, if you would like to derive, but please make sure that you remember the formulas for all these inverse trigonometric functions. So the derivative of, I would like to find the derivative of sine inverse of x. Take let y be, let y is equal to sine inverse of x. Applying sine on both sides, sine y is equal to sine of sine inverse of x. Sine of sine inverse of x would be x. So sine y is x. Now differentiating both sides with respect to x, d by dx of sine y is equal to d by dx of x. Derivative of sine y is cos y into derivative of y is dy by dx. What is the derivative of x with respect to x? Which would be 1. So dy by dx is 1 by cos y. We can simplify this. If x is sine y, what would be cos y? Cos y would be root of 1 minus x square. If sine y is x, because sine square y plus cos square y is 1. So just replace sine y with x, we will get cos y as root of 1 minus x square. So the derivative of sine inverse of x would be 1 by root of 1 minus x square, which we are 100% clear right now. So the derivative of inverse trigonometric function, the first function I am dealing here is sine inverse of x. So the derivative of sine inverse of x is 1 by root of 1 minus x square. Good. Let me solve even for cos inverse of x. So I would like to find derivative of cos inverse of x. So I am taking y as cos inverse of x. The next thing I would like to do here is applying cos on both sides. If I apply cos on both sides, cos y is equal to cos of cos inverse of x. Cos of cos inverse of x is same as x. So cos y is x. Once I get cos y is x, sin y would be automatically 1 by root of 1 minus x square, which I might use later on in my final derivation. So you keep this aside. So if cos y is x, what I am doing is I am differentiating both sides with respect to x. So d by dx of cos y would be same as d by dx of x into d by dx of x. Derivative of cos y is minus sin y into derivative of y, which you have learnt in composite functions with respect to importance of variables dy by dx. The derivative of x would be 1. So dy by dx is same as minus y 1 by sin y. But what is sin y, which I have dealt in the top? Minus 1 by root of 1 minus x square would be the differentiation of cos inverse of x. So let me write the formulas for all other functions which I have seen here. So the derivative of sine inverse of x is 1 by root of 1 minus x square, and derivative of cos inverse of x is minus 1 by root of 1 minus x square. Minus 1 by root of 1 minus x square. and derivative of tan inverse of x would be 1 by 1 plus x square, and derivative of cot inverse of x is minus of 1 by 1 plus x square, and derivative of secant inverse of x would be 1 by mod x into root of x square minus 1 would be the derivative of secant inverse of x, and the derivative of cosecant inverse of x would be minus 1 by mod x into root of x square minus 1, which we have learned. These are all the differentiations of inverse trigonometric functions, which you should be very clear with. Let me recap all the formulas at once. We have learned derivative of x power n, that is same as the power rule. Derivative of x power n would be n into x power n minus 1. From this, what are the derivations we can obtain? First one would be derivative of a constant or the constant function would be 0. Second function is derivative of any linear function which is of the form ax plus b is a, which is same as the coefficient of x. And you can also remember more and more, derivative of root x is 1 by 2 root x, which might help us. Square root function is also important. So these are the observations which we can obtain from the power rule, and these are the things which we have learned in the power rule. Next, we have also learned derivatives of, or we have also learned algebraic functions, which is derivative of f of x plus g of x would be same as derivative of f of x plus g of x, and derivative of f of x minus g of x would be same as derivative of f of x minus g of x. So if you are doing addition, just add the two functions, individual derivative of each function and add them. If you are doing subtraction, do the subtraction of individual functions and differentiate them. Derivative of f of x into derivative of g of x. If I have two functions which I am multiplying them and I would like to find the derivative of them, derivative of, which is called as product rule, derivative of f of x into g of x. The derivative of f of x into g of x would be same as f of x into derivative of g of x plus g of x plus g of x into derivative of f of x. This would be the product rule. Next, we have quotient rule. Quotient rule is, suppose assume you have two functions f of x by g of x, derivative of f of x by g of x is same as g of x into derivative of f of x, g of x into derivative of f of x minus f of x into derivative of g of x by g of x whole square. So product rule, quotient rule, addition and sum. This is algebra of differentiation. Then we have seen derivatives of trigonometric functions. So what is the derivative of sin x? So which is most important, you should remember all these formulas. If you can remember all these, the differentiation topic would be very easy. And derivative of cos x, what is the derivative of cos x? Minus sin x. And what is the derivative of tan x? Would be derivative of tan x is secant square x, and derivative of cot x is minus cosecant square x. Derivative of cot x is, derivatives of all cotangent functions is negatives. So if you can remember that simple basic rule, you can get hold of all these. And derivative of secant x would be secant x into tan x, and derivative of cosecant x is minus cosecant x into cot x. This is secant x into tan x, and derivative of cosecant x is minus cosecant x into cot x. Good. Then we have also seen the derivatives of logarithmic functions, exponential functions. Derivative of ln of x would be 1 by x, and derivative of e power x is e power x, and derivative of e power x would be e power x, and derivative of a power x would be a power x ln of a, and derivative of a power x would be a power x times ln of a. And we have also learned the derivatives of inverse trigonometric functions. Derivative of sine inverse of x would be 1 by root of 1 minus x square. Let me go back to the previous pages which I have written. So if you can just see this, derivative of sine inverse of x is 1 by root of 1 minus x square, and derivative of cos inverse of x is minus 1 by root of 1 minus x square, tan inverse of x, cot inverse, secant inverse, and cosecant inverse. If you can remember these formulas, most of the formulas which you need to remember in differentiation is done. There are many more. And at the same time, you should know how to do the differentiation of composite functions and the importance of variable. Because in next videos I shall discuss about implicit differentiation. When I am doing implicit differentiation, you have very good idea about with which variable you are doing the differentiation. So in these 3 videos which I have explained so far, if you can go through all these videos and you are clear, I am sure the next concepts which I am going to teach you would be very easy for you. Okay, thanks. See you in the next video. Have a good day. Bye.